SpaceX. Go for launch.
Max Q. State separation confirmed.
Landing burn.
Successful spacecraft separation.
Cygnus capture complete.
Welcome to ISS, Cygnus.
You heard in that introduction, welcome to ISS, Cygnus, and that is the theme for today. This is Mission Control in Houston, and good morning from the International Space Station Flight Control Room here at the Johnson Space Center. At this hour, Cygnus, attached to the end of the Canadarm2 robotic arm, where it was captured 1 hour and 43 minutes ago by astronauts Johnny Kim and Zena Cardman, operating the arm from the robotic workstation in the cupola of the International Space Station. Currently, these vehicles are flying 260 miles over Western Africa, moving from southwest to northeast in an orbit inclined 51.6 degrees to either side of the equator. Welcome to our installation coverage, which follows in the wake of a flawless rendezvous by the Northrop Grumman Cygnus XL cargo craft. The craft arriving at the station 1 day behind schedule, but after a flawless rendezvous that was executed following a revised burn plan and some adjustments to the onboard software aboard the Cygnus itself, which triggered an abbreviated shutdown of some of the rendezvous burns that had occurred on Tuesday, forcing a 24-hour delay in its arrival at the station. But good things come to those who wait. And there you see Cygnus loaded with some 5.4 tons of cargo for the Expedition 73 crew aboard the International Space Station as it is slowly being maneuvered into its installation position on the Earth-facing port of the Unity module of the International Space Station by the robotics officers here in Mission Control. As mentioned, about an hour and 44 minutes ago, Cygnus completed its slow, methodical rendezvous to the station, pulling up to a capture point, allowing Kim and Cardman to move in with the Canadarm2 robotic arm. This view from the end effector at the end of the Canadarm2 robotic arm as it latched onto the grapple fixture on the Cygnus. A couple of minutes later, the snares closed, the capture occurring at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, as the two vehicles flew over Central Africa. The installation process, as it begins to unfold over the course of the next hour or so, will call for the vehicle to be maneuvered to an installation point, so its common berthing mechanism, called the passive common berthing mechanism, is aligned with the active common berthing mechanism, which is on the Unity port, the Earth-facing port on the Unity module. Once the two vehicles are perfectly aligned, then the robotics officer will move Cygnus into what is called a capture envelope, allowing 16 bolts, 4 gangs of 4 bolts apiece, to engage and mechanically torque themselves, basically screw themselves into place to form a hard mate for Cygnus onto the International Space Station, where it will spend the next 6 months. The timeline calls for the crew on board the International Space Station to conduct leak checks at the berthing interface between Cygnus and Unity before their scheduled work to open the hatch to Cygnus before they go to bed later today and begin to remove some of the cargo that Cygnus is carrying on board. Today's arrival marks the second cargo ship to reach the International Space Station in the past 4 days. Cygnus arriving at the station just 4 days after the automated docking of the Roscosmos Progress 93 cargo ship that delivered 2.8 tons of cargo, food, fuel, and supplies for the crew on board the complex. Aboard the station in the home stretch of their workday, the Expedition 73 crew seen in this crew portrait, Oleg Platonov of Roscosmos on the far left in the back row, Johnny Kim, who worked with Zina Cardman on operating the robotic arm to grapple onto Cygnus about an hour and 47 minutes ago, the station commander, Sergei Ryzhikov of Roscosmos, and his cosmonaut colleague, Alexei Zubritsky. On the far right is Kimiya Yui of the Japan Aerospace Exploration Agency. And in the front row, NASA's Mike Fink and Zina Cardman. Once again, the robotics officer here in Mission Control is working through a series of carefully choreographed procedures in which commands are sent to the Canadarm2 to maneuver Cygnus to a precise position so it can be aligned to the berthing port of the Unity module on the Earth-facing side of the station. The current estimate is that Cygnus will be within 2 feet of the common berthing mechanism about 35 minutes from now. Once again, this is a very, very slow process, but one that is deliberately crafted so that the vehicle, because it has to be maneuvered into position, does not automatically dock, such as a Progress or a SpaceX Dragon cargo craft. This vehicle, the Northrop Grumman Cygnus XL, as was its predecessor, the original Cygnus cargo craft, and the upcoming Japan Aerospace Exploration Agency HTV-X1 cargo craft that is scheduled to launch from the Tanegashima Space Center in southern Japan on the night of October 20th U.S. time, October 21st Japan time. Those vehicles have to be captured, as was Cygnus this morning, and then maneuvered into place for mechanical installation into these common berthing mechanism ports. Once the Cygnus is precisely aligned into the capture envelope, as it is called, 4 capture latches will pull the Cygnus basically into position, allowing 16 powered bolts to be commanded to complete the rigidization of the structural joint, sealing the interface between the passive and active portions of this common berthing mechanism on either side of the berthing interface. The powered bolts are driven into position and torqued by the closed-loop speed control systems of the common berthing mechanism. There are bolt controllers and bolt actuators that firmly torque these bolts into place, very much like a power tool would screw in screws to a structure. And Cygnus will be permanently attached for the duration of its 6 months on the International Space Station. There will be 2 call-outs from the OSO, the Operations and Support Officer here in Mission Control, basically the Mechanical Systems Officer. First stage capture, that's basically the preliminary capture point for Cygnus on the common berthing mechanism, followed by second stage capture, and at that point we can declare that Cygnus is firmly attached to the space station for the start of leak checks and the opening of its hatch by the Expedition 73 crew later today. Cygnus was launched from the Cape Canaveral Space Force Station in Florida off of Pad 40 on Sunday evening at 6:11 p.m. Eastern Time atop a SpaceX Falcon 9 rocket. The Falcon 9 delivered the Cygnus with spacecraft separation occurring about 14 minutes and 45 seconds after its launch. Cygnus began a stair-step approach to elevating itself through a series of rendezvous burns to match the altitude of the station. Everything went by the book until very early Tuesday morning, when the software limits that were conservatively calculated for the Cygnus burn plan prematurely shut down a pair of engine firings before their completion, leaving Cygnus in a trajectory that would not have been compatible with a rendezvous to the International Space Station. Northrop Grumman engineers sharpened their pencils, went back to the drawing board, consulted with NASA engineers as well, and devised a revised burn plan that phased Cygnus to a point about 500 kilometers behind the International Space Station, where the revised burns began to be executed under adjustments to the software itself. All of the burns on Wednesday night and all through the early morning hours this morning, however, were perfect. Everything was flawless in the final phases of the rendezvous that brought Cygnus to the station for its grapple by the Canadarm2 robotic arm at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, as the two vehicles flew over Central Africa. We have a short loss of signal from the International Space Station while we pass in between satellites on our tracking and data relay satellite system. Once again, Cygnus is gently, carefully, methodically being maneuvered into an installation position to align its passive common berthing mechanism with the active common berthing mechanism on the Earth-facing port of the Unity module of the International Space Station. These berthing mechanisms are comprised of latches and bolts that essentially torque down and bolt the vehicle into place for its planned 6-month stay on board the station. All quiet here in Mission Control in Houston. The Northrop Grumman engineering team of flight controllers continuing to watch over Cygnus's systems from their vantage point at the Northrop Grumman Mission Control Center in Dulles, Virginia. The two flight control teams working in tandem with one another throughout the course of the overnight hours to guide Cygnus in for its capture almost 2 hours ago. Cygnus is in great shape, receiving power at the moment through the robotic arm itself. Once it is attached and bolted into place on the Unity module of the station, it will receive space station power for the duration of its stay on board. The current plan calls for a late November detachment of this Cygnus cargo craft from Unity, basically reversing course from what we're doing at this hour. where it will be left in an overnight park position for 2 days to allow the Soyuz MS-28 spacecraft to arrive at the station for a berthing at the Rassvet module of the International Space Station on the Earth-facing side of the Russian segment of the station. That will alleviate any undue loads being placed on the cargo craft by the approaching Soyuz craft that will deliver NASA's Chris Williams and Russian cosmonauts Sergei Kudz-Sverchkov and Sergei Mikhaev to the station for the start of their 8-month mission. Once the Soyuz has been docked, that's scheduled for Thanksgiving Day, the Cygnus will be basically doing exactly what it's doing this morning, and that is maneuvered back into position to be reattached to the station for the remainder of its stay on orbit. This view of Cygnus shows the business end of the vehicle. Basically, that is the passive common berthing mechanism. External cameras on the station conducted a survey of that apparatus following its capture to ensure that there would be no foreign object debris or any other untoward situation mechanically. With that end of the Cygnus, that will be the end that is physically attached and bolted into place on the common berthing mechanism on the Unity module. Here in Mission Control, once the installation of Cygnus is complete, we will have a shift handover to the Orbit 2 team. The lead flight director for Cygnus operations is in the middle there at the flight director console. That is Garrett Hain. To his right is spacecraft communicator Aaron Edwards, who has been talking to the station crew throughout the course of this morning's rendezvous operations and again through the installation coming up. And at the bottom of your screen is Flight Director Ronak Dave. He will be taking over as the Orbit 2 Flight Director following Cygnus's installation and its bolting into place. It has been a busy period on board the International Space Station with the arrivals of the Progress 93 cargo ship this past weekend, today's arrival of the Northrop Grumman Cygnus XL, the new version of the Cygnus cargo craft, dubbed the SS Willie McCool, named in honor of the late astronaut who tragically lost his life in the Columbia accident on February 1st, 2003. Coming up in just a few weeks from the Tanegashima Launch Complex in southern Japan will be the Japan Aerospace Exploration Agency's launch of its H-3 rocket to carry the new HTV X1 cargo craft into orbit. It will spend 3 days phasing toward the International Space Station. That launch is scheduled for the night of October 20th, 8:58 p.m. Central Time, which will be 10:58 a.m. Japan time on October 21. HTV X1 is scheduled to arrive at the station for its robotic capture and installation on October 24th. HTV X1 will be attached to the Earth-facing port of the Harmony module. Between Progress's arrival the other day and Cygnus's arrival today, a total of more than 8.3 tons of cargo will have been delivered to the station, and adding to that the more recent arrival of the SpaceX 33 Dragon craft, complete with a reboost kit in its trunk to provide reboost capability for the station, saving propellant for the Russian vehicles that are also bear some of the load for reboost and debris avoidance maneuver capability for the international outpost. We will be reacquiring our downlink video capability from the station momentarily on the tracking and data relay satellite system. The station with Cygnus firmly in tow.
Station on 2 with a question on my upcoming Earthshine activity.
Go ahead on 2.
I just want to make sure that you all are okay with me opening up the cupola shutters in order to complete this activity.
Checking. All right, Johnny, your go to open those shutters for your activity.
Okay, thank you very much.
Johnny Kim aboard the station, acknowledging Aaron Edwards, the spacecraft communicator here in Mission Control, just checking to make sure that the shutters on the cupola can be reopened now that activities have shifted from robotics that he and Zena Cardman were involved in earlier today to the installation, which is under the control of the robotics officer here in Mission Control, the Robo, as is his call sign. The station and Cygnus are currently flying 260 miles over southeastern China, about to begin a northwest to southeasterly track to carry it across the Pacific Ocean. We are about 32 minutes until we move into an orbital sunrise. And again, the slow, methodical maneuvering of Cygnus to its alignment position, where its berthing mechanism will be precisely aligned with the common berthing mechanism that will capture it basically on the Earth-facing side of the Unity module of the International Space Station, to enable 16 bolts to be driven mechanically to firmly latch Cygnus to the station for the remainder of its stay on orbit. This is Mission Control Houston. It has been about 2 hours and 12 minutes since the Cygnus XL, the Northrop Grumman cargo ship, was captured by the space station's robotic arm under the control of Johnny Kim and Zena Cardman, who worked those procedures from the cupola workstation on the International Space Station. At this hour, Cygnus is hovering over the common berthing mechanism on the Earth-facing side of the Unity module, being aligned for its ultimate installation into what is called a capture envelope to enable a series of latches first to pull Cygnus in for the beginning of the bolting of Cygnus into place by 16 bolts, 4 gangs of 4 bolts apiece. This view is from a camera in what is called the centerline camera berthing system. This is a visual alignment tool that is used to ensure the precise alignment of the Cygnus's berthing mechanism with the common berthing mechanism on the Earth-facing side of the Unity module. The robotics officer here in Mission Control reports that he has one more maneuver that will take about 4 minutes to complete, that will place Cygnus within 2 feet of the Unity to begin a more precise alignment before it enters its capture envelope. This is Mission Control Houston. Just to recap, you're looking at the Northrop Grumman Cygnus XL cargo craft, which executed a flawless rendezvous this morning to arrive at the International Space Station, where it was grappled 2 hours and 16 minutes ago at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, to complete a 4-day journey following its launch Sunday evening from the Cape Canaveral Space Force Station in Florida atop a SpaceX Falcon 9 rocket. Loaded with more than 5 tons of cargo for the Expedition 73 crew, Cygnus is in the home stretch before its berthing and bolting into place on the Earth-facing side of the Unity module of the International Space Station. Cygnus, which is at the end of the station's robotic arm and the International Space Station, flying 260 miles over the western Pacific Ocean, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator. All of Cygnus's systems operated flawlessly throughout the course of its rendezvous in the overnight hours. It wound up right where it was supposed to be, following a revised burn plan that was devised by Northrop Grumman in the wake of two abbreviated shutdowns of main engine firings in the early stages of the Rendezvous sequence, attributed to overly conservative software limits that had been established pre-flight. Those software limits were adjusted, a new burn plan was executed, and done so in flawless fashion to bring Cygnus to its eventual home at the end of the robotic arm, and where it will be bolted into place on the Unity module a short time from now. Once we get to the actual installation of Cygnus, you'll be hearing call-outs for first stage capture and second stage capture. These are two phases of the installation process for a vehicle that is being mechanically bolted into place on these common berthing mechanisms. The bolting itself is conducted in several stages. The first stage acquires all 16 bolts and their mating nuts and torques them into an acquired bolt preload of some 1,500 pounds that is measured by strain gauges within the bolts and monitored by the operations and support officer, the mechanical systems officer here in Mission Control. After this initial torque is complete, further torquing is discontinued so that temperatures between the passive ring and the active ring, essentially both sides of the berthing interface between Cygnus and Unity, can be equalized. The bolts are ultimately commanded in groups of 4. There are 4 gangs of 4 bolts apiece, 16 in all, to a final load of over 19,000 pounds per bolt, ensuring a rigid and permanent structural mating of the cargo craft to the International Space Station. Again, a view from external cameras on the International Space Station showing the Cygnus cargo craft slowly but surely being aligned with that circular mechanism. That's the common berthing mechanism on the Earth-facing side of Unity. We're just a few minutes away from what is called the pre-install position, where Cygnus would be 2 feet away from the common berthing mechanism on Unity. Once it moves into that capture envelope, we'll be hearing calls for RTLs, that's ready to latch indications from the mechanism itself, the common berthing mechanism. On the station side, it's called the active common berthing mechanism. The passive side is on the Cygnus side. The chatter here in the flight control room centers around Cygnus being moments away from being in the pre-install position.
Go ahead, Mike. We're with you on 2.
Yes, good morning. We are finished with the velocicalc measurements, and the next step would be to remove the node 1 diffuser covers.
All right, Mike, we have a couple safing actions we need to take from here, so I'll get you to stand by for 2 minutes. I'll get back to you.
Well, no hurries. I'm still putting away the velocicalc meters, so take your time. Just let me know when you're ready.
We will do, and while I have you, Mike, I copy your your crew note there about the temp stow, the battery. We're happy with that. We'll keep watching that for the next day.
Okay, I'll hold on to the battery, and then you'll let us know via daily summary or something that we should discard it or keep it. Thank you.
The Cygnus cargo craft, loaded with more than 5 tons of supplies for the Expedition 73 crew, is almost at its parking place on the Unity module of the International Space Station. Everything has gone very smoothly all through the morning. A textbook rendezvous that resulted in its grapple by the Canadarm2 robotic arm at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time. The robotics officer here in Mission Control has maneuvered Cygnus to what momentarily will be called the pre-install position for a final alignment before it is guided into the RTL, or ready to latch configuration, where latches and the common berthing mechanism on Unity, that circular device that you see almost right at the interface with Cygnus, will begin to draw Cygnus in flush, so that both sides of the berthing interface are flush against one another, enabling the start of the bolting of 16 bolts, 4 gangs of 4 bolts apiece, to mechanically attach Cygnus to Unity.
At this time, thanks.
The International Space Station and Cygnus flying 260 miles over the Pacific Ocean, passing over Samoa, the Cook Islands, and Tonga, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator, as we are in the home stretch of Cygnus's arrival at the complex. With the space station now in what is called momentum management, essentially ensuring that there are no untoward maneuvers that are planned for the space station during the final stages of this delicate installation operation. The robotics officer is estimating that we're about 15 minutes away from being at the RTL or ready to latch position, which will set the stage for first and second stage capture of Cygnus, which amounts to the initial two phases of the bolting and bolt loading process that will physically attach the spacecraft to the international outpost. As mentioned earlier, we will be reversing this process and detaching Cygnus from Unity in the November 25th timeframe, a couple of days before the Soyuz MS-28 spacecraft launches from the Baikonur Cosmodrome. That's scheduled for Thanksgiving Day, with NASA's Chris Williams and Russian cosmonauts Sergei Kudzverchkov and Sergei Mikhayev on board to begin their 8-month mission on the complex. That is scheduled to be a two-orbit rendezvous. That vehicle is going to be docked to the Rassvet module on the same Earth-facing side of the station as is Cygnus. The goal in mind here is to prevent any inadvertent loading onto Cygnus by the arrival of the Soyuz spacecraft. So it will be detached by the robotic arm and moved into what is called an overnight park position to allow Soyuz to dock. Following the docking of Soyuz, then Cygnus will be reattached to the Unity module, just as you're seeing in this view from external cameras on the station. So this is the first of several acts of attachment, detachment, and reattachment for the Cygnus spacecraft during the course of its 6 months at the International Space Station.
Station on 2 for Moonshine.
Go ahead, Johnny. We're with you on 2.
Okay, I'll get a couple more eyeballs to back me up, but I'm looking outside windows 1, 2, and 6, and I cannot find the moon. I should be able to see it now, and I'm wondering if it's behind the arrays.
All right, we're checking, Johnny.
Cygnus now being maneuvered into what shortly will be the ready to latch position. It's been just over 2.5 hours since its capture. Johnny Kim and Zena Cardman were operating the station's robotic arm.
The array was blocking, and now we have a good visual of the moon.
You found the moon. Fantastic.
Cygnus was grappled at 6:24 a.m. Central Time, 7:24 a.m. Eastern Time, as Cygnus and the station flew 260 miles over Central Africa. And the robotics officer reports that the Canadarm2 that is in the grasp of Cygnus is pushing in for ready to latch indications. And we now have 4 ready to latch indications. This is the precursor to the start of the bolting of Cygnus into place. There are 16 bolts in all that are torqued into place in 2 stages, so that we have a hard mate between Cygnus and the Unity module, to which it will reside for the next 6 months. A view of the flight control room here at Mission Control in Houston, as the shift handover is just beginning, as we are Just a few minutes away from the final bolting into place of Cygnus to the Unity module, following a flawless rendezvous this morning and a robotic capture of Cygnus that occurred 2 hours and 41 minutes ago. And the robotics officer is about to place the arm into what is called limp mode, essentially disabling it from any further motion to provide a quiescent state for the start of the bolt loading. With the arm now in limp mode, first stage capture is complete. Standing by for confirmation of second stage capture. We're in a brief handover between satellites on the tracking and data relay satellite system. We are in the process of standing by for confirmation of second stage capture and the bolting of Cygnus into place. Still awaiting confirmation of second stage capture. We should be getting that momentarily.
Houston Station for Node 1 diffuser covers.
We're with you on 2.
All right, the diffuser covers are removed and we are ready for IMD activation. And just as a cool thing, sounds like we're hearing some common birthing mechanism IMCA motors turning. So good luck.
Roger, we copy the covers, and yes, I think we're making good progress with the mate.
Good, Cygnus. I think progress was a week ago. Ha ha ha.
Aboard the station, NASA astronaut Mike Fink relaying that he can hear the bolting of Cygnus into place. We're standing by for confirmation of second stage capture. That essentially will be the hard mate of Cygnus to the Unity module. This is Mission Control Houston. The mechanical systems officer here in Mission Control reports that Cygnus has been mechanically attached. We do have a hard mate now with second stage capture. That coming at 9:10 a.m. Central Time, 10:10 a.m. Eastern Time, as the International Space Station and Cygnus flew just off the coast of Chile. So with that, Cygnus's arrival at the station is now complete. There are 3 cargo ships now at the station, the SS Willie McCool, the Roscosmos Progress 93, and the SpaceX Dragon cargo craft. All of that food, fuel, and supplies having been delivered to the International Space Station. This will kick off several hours of leak checks at the Cygnus Unity docking or berthing interface before the crew presses into hatch opening and the beginning of the unloading of cargo later today. Once again, Cygnus now hard-mated, firmly attached to the station at 9:10 a.m. Central Time, 10:10 a.m. Eastern Time, not quite 3 hours after its robotic capture, following a flawless approach, rendezvous, and terminal phase of its approach to the station. Everything went by the book throughout the course of the morning. With that, we will wrap up our coverage of Cygnus's arrival at the International Space Station. Cygnus, now firmly attached to the station, will receive station power shortly, and its hatch will be opened later today. So with that, we wish you a good day on this Thursday. We'll be signing off for now. This is Mission Control Houston.